This talk is going to be about streamlining the inner loop of our development cycles with distributed systems. If some of those terms seem a little weird or something, I'll explain it, so no worries about that. So my name is Kevin Dubois, like was already said. So I'm a developer advocate at Red Hat and also a Java champion. And you can connect with me with any of those social media handles as well. I'll share that at the end as well, so don't worry about it. So when we're talking about inner loop, right? So what exactly does that mean? So if you think about inner loop, basically it's the cycle where you do your local development, maybe do some debugging, hopefully some testing of your software as well. And then at some point, your code will be, more or less good enough, and you'll push it to a repository. So that whole cycle, and that can be a couple iterations, right? Because we push our code and then we realize, oh, I forgot this, or maybe I need to adjust that, or maybe we need to debug this. So that whole cycle is basically the inner loop. So that's what we're going to be talking about today. And then the outer loop is basically after you commit your code, somebody might do a peer review. You'll probably build your application in a continuous integration kind of system, and then eventually deploy it, perhaps in an automated fashion. And that's basically the outer loop. And then, of course, ideally at some point it goes to production as well, right? So that is, of course, the outcome. So today, again, we're focusing mostly on the inner loop of our development cycles. So basically, it's all about, getting a quick feedback loop, right? Because if we're developing our code and then a month later we realize that there's an issue, we have to go back to it, that's not so ideal, right? I don't remember what I wrote a month ago, probably not even a day ago. I didn't have to go read through my code again to figure out, like, what was I trying to do there? So the quicker we get feedback of there are some issues, or maybe there are tests that are broken, maybe there are some security vulnerabilities. The quicker we get that, the more productive we can be, and the more we can speed up this inner loop, right? Now, the inner loop of our development is one thing if we are doing it in, just one small application, or even a larger application that's more monolithic in nature. But these days, our systems are more and more distributed, right? We have more and more different services, microservices maybe, serverless components, and it becomes more and more complicated to do our inner loop development because there are external dependencies that we also need to take care of and interconnect, right? But ideally, we still want to have quick feedback loops, right? Because if we develop on our local machine and we don't have the integration with the other components, it may be that it all works on our local machine, and then once we go into a testing / staging / UAT environment, that we realize there are issues, and again, that's not so ideal. So I'm going to be talking today mostly about Quarkus, which is a Java stack that helps not only speed up your applications in terms of performance, you may have heard about that, but it also has some really cool features to help with our inner loop of our development. So maybe a question to get started. How many of you are Java developers? Nice, I see most of you, that's excellent. And how many of you have heard of Quarkus? So about maybe 40%, 30 to 40%. And how many of you actually work with Quarkus right now? So just a few, okay. That's great, because hopefully I can show you some cool stuff about Quarkus as well. Now, that doesn't mean that this talk is just about Quarkus. It's just what I use and what works for me. But I will mention, some alternatives. I'm assuming many of you are using Spring Boot. That's kind of the most popular stack these days, right? So you can do most of what I'm doing with Spring Boot as well. The only difference is that with Quarkus, it kind of comes out of the box, and with Spring Boot, you kind of need to do a little bit more configuration. But yeah, I'll keep in mind that you're not all Quarkus developers, and that's okay. So I'm going to start out with a really small demo just on my local development, a very small application that I'm going to start from scratch, just to kind of get into the flow of things when I'm starting a new application. So to do that, I'm going to create a Quarkus application. So I could go to quarkus.io. I can show that even. So if we go to quarkus.io, got a nice little light show going on here. We can see that, you know, there's a start coding, and if you're familiar with Spring Boot, you will be familiar with this kind of concept of the, you know, the starter, where you select, you know, your dependencies, and then you can generate an application. So that's one way to get started. You can use plugins for your IDE, so IntelliJ and VS Code and stuff like that. But I'm just going to use the CLI here. So I'm going to create a new application, Quarkus create app, and then let's call it GIDS. And once that's created, we'll give it just a second. Hopefully our internet's nice and cooperating. If not, I'll start a hotspot. Give it just a second. Oh, there we go. And then I'm going to open this up. We'll do VS Code in this case. So I have a little application here, right? So it gives me a little bit of starter code as well. And we can see here that we have a main, Java, and then greeting resource. So if you're familiar with Java EE, this should look fairly familiar with you. Yes, it's now Jakarta, of course. And you can see there's just a little REST endpoint that says hello, and then it says hello from Quarkus REST. So we can change, well, actually, let's start with our inner loop cycle, right? So I want to run this on my local machine and then keep getting feedback on how things are going. So I can do Quarkus Dev, or you can do Maven, Quarkus Dev, and this also would work for Gradle as well. You can do Gradle, Quarkus Build. And by doing this Quarkus Dev, basically I'm starting up my application on my local machine. And what's cool with this dev mode is that it's going to continuously update my applications. So as I'm developing, it'll do hot reloads. And so let's try that. So I'm going to go here. We've got limited real estate, so we have to be a little bit careful here. So we'll do hello from GIDS. And I'll go to my browser. And we'll go to localhost 8080, where our application is running. And we can see that we have this landing page, and on the /hello endpoint, we see hello from GIDS. That's no surprise, right? So now what if I make a change and we say hello from Bangalore? Again, I'm not making any kind of recompilations or anything. I just hit refresh, and it, you know, automatically picks up my my changes. So for me personally, for my inner loop development, that already makes a nice big difference, right? So one thing that I'm kind of sometimes a little bit terrible at is I make code changes and then I forget that there's actually, of course, tests, right? And so there is, in fact, there is a test already in this starter application, and it's looking for hello from Quarkus REST. So I just broke my build basically, right? But, so instead of having to realize this when I finally do my package of my application, if you've noticed here in this output, you can see here that it says press R to resume testing. So this live mode, I can also enable it for my testing as well. So if I hit this R, now we can see that, oh, my test is failing, right? And so if I now fix my tests, hello from Bangalore, I think that's what it was. It's automatically rerunning the tests for the code that I've changed. So in this case, of course, it's the test itself. But if I went back to my code and I changed it, I want 2 exclamation marks because I'm very excited to be here, then my test fails again, right? But I get that quick feedback loop of, hey, you know, make sure that your tests are in compliance as well. So that's our first little step of our inner loop development. So my test is passing, which is great. Let's go back to our slides here, and then that was easy, right? I mean, there's no kind of magic here. I just had a REST endpoint, and I started live mode for my Quarkus application, and I started my testing, and it all ran automatically, so I get quick feedback loops as I'm developing. But of course, this was a very simple application, right? Because it doesn't even have any dependencies. What about, what if we add then a database or a messaging system or something? Now, that means that we have to start creating databases on our local machine or connecting it with an external database somewhere, or maybe you were working with Kafka. Now you need to set up, some sort of a Kafka system on your local machine. So that's not so ideal if we want to iterate quickly, right? Especially like we have to then create the schemas and then make sure that they're the same kind of system as that we're using on production. So a project that really helps with that is TestContainers. So who of you has heard of TestContainers? Okay, so not as many as I thought. TestContainers is a really interesting project, and this works with Spring Boot as well, to help you in your inner loop development to create the resources that your application is dependent on. So for example, a test database or a messaging system, or there's a whole bunch of different dependencies that work with TestContainers. And so the idea is that when you run your tests, it'll start up a container with your dependency and then wire it up with your application, run the tests, and then tear that container down so you're not necessarily using all those resources when you don't need them. And it's a really cool project. I definitely recommend taking a look at it. What's interesting is that with Quarkus, TestContainers becomes even more powerful because Quarkus kind of out of the box leverages TestContainers to work with this concept that's called Dev Services. And so basically this Dev Services uses the same kind of live reload concept that we were using for our very simple application to, when I add a dependency to, like for example, a database, it'll start up that database as I'm developing, connect my application to it, and then I can get quick feedback loop of, a little more complex application. So let's try that, right? Let's take a look and see how that works. So I'm going to stop my application here, and I'm going to cheat a little bit. I'm not going to write all this code because we don't have 5 hours here. So I have another little application which is called Quarkus Observability, which uses a database already. So if we go to the pom.xml, you can see that we're still using REST, and then we're also using Hibernate, and we're using a Postgres database. So when I start this application up in my, again in this Quarkus dev mode, keep an eye out on the outputs of the logs, and we'll see hopefully that some magic is going to happen. So let's take a look and see. So it's starting up our application, and at some point you see that it's checking for Docker environment, and now it says database for default data source, container Docker IO Postgres 14 is starting. So what happened here is that the Quarkus application noticed that, hey, you want to start up this application on your local machine, and you have a dependency on a Postgres database, but you don't actually have one running on your local machine. So we're going to use TestContainers to start up a container with Postgres, and then also create some application properties to connect to this database. So let's take a look at our container environment here. So I have Podman Desktop installed. So if you're familiar with containers, you may have heard of Docker. Maybe you've used Docker. Podman is basically an alternative to Docker that's fully open source, so there's no kind of licensing costs involved here. And so Podman Desktop is a nice user interface, which you can actually use with Docker Engine as well. I'm using Podman Engine, but that's not necessarily so relevant. But we can see here that 1 minute ago, Postgres database was started up on this random port 38.931. and that's been wired up to my application. So if we go now to localhost 8080, we're not going to see hello from Bangalore anymore because this is a different application, right? So it says, let's start observing, kind of a very lame text. But we can see here that, we have a Quarkus application running. And I believe, let's see what endpoint is. I think it's /places. So if we go to here, places resources, we can see that I have this little application that's going to return some of the places that, that I've spoken at in the last few months. So let's go and take a look and see if this is actually up and running. So localhost 8080/places, and we can see that, yes, sure enough, we have the places here, and yes, Bangalore is on there too. That's the latest place, right? So this is up and running, connected to the database without me having to create a database, set anything up. So again, if we go back to that, my statement about, we need fast, quick feedback loops, this helps, right? Because now if I make changes, they're going to be changed on the fly. So I could say, I want to add some more logging. Kevin was here. And if I do that, and we go to our application, and I hit refresh, and then we go back to our console, to our terminal, we should see somewhere along the lines that Kevin was here. And let's see. It's somewhere around there. You'll just have to trust me, I guess, unless I did it in the wrong place, but that's okay. So what we also see here is that it's trying to connect to this tracing system, to Jaeger. So that actually I did not wire up. I did not tell Quarkus that I want this dependency. That's okay. I'll show you in a little bit some other ways that we can work in our inner loop for things that aren't dev services. Question?
How do you indicate that this project needed a container with the database?
Yes, that's a great question. So if we go to our pom.xml, so what I showed you earlier is that I have this dependency on Postgres right here. And so this is a Quarkus extension. And Quarkus extensions are basically kind of like dependencies, but they wrap some extra functionality. So what you can build into your extension, if you create extensions for Quarkus, is that you can create the logic for dev services and for test containers. So in this case, this Quarkus JDBC Postgres has that knowledge to say, like, hey, start up a database if you don't have one configured in your application properties. So here's kind of the funny thing, though, is that I do have the data source defined on my in my application properties, but I have this %sign prod, and that basically means that I only want to apply these properties if my profile is prod, and so it's not seeing anything for when I'm running in dev mode, because then by default the profile is dev, and so that's how it's like, well, you don't have anything configured, so I'll start it up for you. So I can show you this in the Quarkus dev mode as well. So if you run Quarkus in dev mode, you can also go to q/dev, and then you see kind of all the stuff that's working in your Quarkus application. And you can see, for example, that we have Hibernate ORM in our dependencies. We're running REST, of course. I also am exposing some metrics with micrometer. And then you can see here on the left, there's a dev services. And here we can see the configuration that Quarkus configured for me. So we can see here that it set up this Postgres database. And you can see here the port that it randomly creates. So it checks to make sure that this port is available on your local machine. And then we'll map the port of your test container to your application through this. Excuse me, just a quick drink. Yes.
Just to say we need to map the container code to the application. How we can map?
So this happens implicitly by the Quarkus Dev Service. So it's going to do the mapping for you.
We need to find the port, or it will automatically assign some random port?
It'll automatically assign a random port. Now, if you want to use a specific service, if you already have a database running on your local machine, or maybe you want to connect to an external database, that's perfectly fine too. Then, as long as you've already have it configured, then the dev service will not start, right? It's only if you don't have anything started yet. Sorry? It's not an in-memory database. It's an actually fully fledged Postgres database running in a container. Yeah, so if you go to our Podman desktop, you can see here, this is an actual container running Postgres database. Sorry? On my local machine, yeah. Yeah, exactly. So the only requirement is that you do have to have a container engine running, right? So Podman or Docker are kind of the defaults, yes. Yes, so the schema is initialized by my configuration of my entity. So I have a place entity here, and that's basically going to tell the dev service to set up that system. And then the data that's in there is an import SQL basically that I have added, which the dev service will also automatically use if you don't have anything else configured. It'll notice like, oh, you have an import SQL, I'll import your data automatically. So let's move on to the next part of our presentation, which is kind of this, right? So maybe this is great if you have, again, a fairly small application, you have a database dependency, maybe some other dependency, but what now if you have a more complex distributed system, right? Because that's what we're going towards here in the talk, of course. So you can see here some examples of some systems where you're using, where they have a lot of microservices, right? So this kind of represents, like, well, this service needs to be able to talk to all those services and that service needs to talk to that. So that's not so ideal to set that all up on your local machine, right? So that becomes a little more complex. How do you integrate all those different components and how do you get it all kind of synchronized? That's a lot, right? So let's explore some options. So I'm quoting myself here from a few years ago when I was working at Target. I don't know, are there any developers, Target developers here? Because I saw there's a Target booth and I'm like, oh, that's cool. I used to work for Target. But anyway, so back in, I think 2015, 2016, we had a fairly complex system with different microservices. And it was quite a pain to run this on our local machine to get that quick feedback loop, right? So what we had was, we had all our services deployed on a test environment. And then basically, I'm doing my local machine, my development on my local machine of one of the services. And then, like I was saying before, there wasn't an ideal integration if we had to connect with external services. So I could connect with some services running in a cloud environment, but then some other developers also using that. So there's some conflicts. So it wasn't so ideal. So we needed to figure out some way to do this better. And fortunately, by 2016, containers were becoming a thing, right? And so I started containerizing all these different applications, and we were actually able to run several of them on our local machines so that we could have a much quicker feedback loop and easier integration between systems. So in my opinion, containers are pretty indispensable for distributed systems where instead of compiling multiple applications on our local machine, running them all individually, configuring them all individually, with containers becomes a lot more easy, right? Now, there are several solutions for containers, right? So like I already mentioned, Docker and Podman are the main ones. And Docker and Podman also supports Docker Compose, which makes it easy if you're working with multiple containers to tie them all together, right? Because otherwise, yeah, starting up one container is one thing, starting up another container is another thing, but how are they going to talk to each other, right? Because the idea with containers is that they're kind of their own, running all in their own little namespace and their own network, and once you start connecting them, well, you have to go outside of your container to another container. But that's not really how it works in a cloud environment like Kubernetes, right? In Kubernetes, you have private networks, so you want to be able to kind of mimic that a little bit better. So that's where, under your local machine, yes, you could run Kubernetes, and that is absolutely a solution, but then, of course, you need to be a little bit familiar with Kubernetes, or you could use Docker Compose. So let's do another little demo here. To work locally with a little more distributed system. It's not super complicated, but it's a little bit more, right? So in this case, I have this voting app, and I have a UI that when you click vote for your favorite IDE, I know that there are elections going on here. I didn't go in that direction with vote for your favorite politician. We're going to vote for our favorite IDE, which may be more controversial than political, but so anyway, so we have our UI, and we call this REST service, which is going to receive your vote. And then, of course, it's a little bit over-engineered. So the vote is going to go into a messaging system, into a Kafka. And then on the other end, I have an application listening to the messages that are coming through this Kafka topic, and then insert those in the database. And then my UI is going to collect the information from the database to show the results. So that's an application with multiple components. So that makes it already a little bit more complex to do, right? So this is the UI. I'm sure you can see that I'm not a front-end developer. So let's go to this application. So I'm going to stop my live mode for our Quarkus observability, which you can find on my GitHub as well if you want to check it out. And you can also see how it interacts with observability. So it does the tracing and metrics. Excuse me. This will automatically stop the database. Yep. Sorry, I had a cold 2 weeks ago and my throat is still struggling. So I'm going to close this. Apologies. Sorry. Can I run the container on a remote machine? Yes. So you can, so one way you could do this is, so when I start the dev services, it's going to pull down a container, which is going to run with TestContainers. But you can actually use this container in our images. Apologies. We can see here, here's that database. And so what I could do is I can say, well, I'm going to tag this as my as my version of the database, and then push it to a registry and then use that. Would I recommend you go on this route? It depends. If you're going to do like more like a remote development environment, then yes. Would you use this database directly on production like this? Probably not, right? You want to make sure that your platform engineer, database administrator or something is maybe involved in that process to select the right version of the database and creating the schemas. Probably not on the fly with just what we created from our dev services, but you know, it is a good start to then build upon that. All right, so I'm going to go and to my voter application. So this is using Apache Camel. Any Camel people here? 1, nice. 2, 3. So this is using Camel Quarkus. So it's the UI is a Quarkus, a full regular Quarkus application, and then the other components are using Camel Quarkus. That's just to integrate with the database, with the Kafka systems. So in this case, we have again a fairly simple application. It's just a few more components, and we see here that we have fairly similar components, right? So we have Quarkus application, and then it's calling those camel Quarkus components. So one thing that I could do is I could start my dev mode, but since I have a dependency from my UI to this ingester component, to this processor component, I would have to start up multiple systems at the same time. So I could do that. I could run multiple Quarkus devs at the same time. So I could go into, let's say, the processor part, and then do Quarkus dev. And this component has a dependency on Kafka and on Postgres. And so we'll see that. No kind of surprise because I already said it, but it's starting up the Kafka dev service and then the Postgres service. So it's going to start that up for me, which is which is pretty handy. So I can do my local development on this particular component. So in this case, we can see again there's a Postgres database. We have our TestContainers container that's monitoring these systems, and then we have the Kafka container based on a version from Red Panda. And so now if I go to my local host, and I think this is running on a different port, it's running on 82 maybe, let's see, yes. We can see that this is also a Quarkus application, and we can see that it has an Apache Kafka client. I can even go and look and look at the topic, so we can see that there's a votes topic. And technically, in this Quarkus dev mode, I could even create some messages that go into this Kafka topic, all running on my local machine in this dev services. So that's pretty handy. But again, like I said, we have multiple components. So to be able to test my entire application, I'd have to start up multiple dev modes. And at some point, it's not so ideal, right? Because I don't have the UI running right now, so localhost 8080 does not resolve to anything. So to be honest, I do run most of the time when I'm testing the 3 dev modes at the same time, but I wanted to show you that you can also leverage the containers to run it on our local machine with Docker Compose in this case. So I'm going to go up one directory, and I'll show you the Docker Compose here. So who's familiar here with Docker Compose? So about half of the people here. So Docker Compose makes it a little bit easier to orchestrate different containers, put them in the same network so they can talk to each other, and then we can configure things a little bit more easily. So in this case, we can see that we have our Postgres database, we have Kafka, working with Streamzy, we have a camel demo UI, we have an ingester part, and then we have a processor part. So we have our different containers that we're orchestrating, and then we can map our ports accordingly, because we can't all run them on the 8080 port, right? And then in the environment variables, we can set, hey, you need to talk to this database from this component, and then from the UI, we want to be able to talk to our processor API, and so on and so forth. So let's start this up. So Docker Compose up. And so the way that I have it configured right now is in my Docker Compose, I set it to build a container when I start up the Docker Compose, so that it picks up the latest changes from my application. Let's see, what is it saying? Oh, so I need to compile my applications. I guess I did a clean at some point. So Maven package, this is going to take a little while because there are multiple applications. So of course, when I do my container build, it's going to, the different Docker files are going to look for the artifacts that have been built during our build process, put those in a container, and then build a container image from that. So that's what you see happening here. So while that's running, maybe I can show you some interesting things about these applications. So when you create a Quarkus application, you actually get some Docker files kind of out of the box. So, and that's what's happened here, right? So we have a Dockerfile JVM. We have, for example, a Dockerfile native. And so basically I can create containers for my application without being experts in how to create a Docker file, how do I copy files into it, and so on and so forth. So in this case, we can see that we're using a base image that is tested and verified by Red Hat in this case, which uses a supported version of OpenJDK as the base image, and then it's going to copy the Quarkus artifacts into that, and then basically start up the application and make sure that the port is exposed and stuff like that. So I didn't have to do any of that. That comes with your Quarkus application, so that's pretty nice. And then you can just build your container image with Quarkus too. You can just do Quarkus image build, and that would start a container build for my application. Now, if I wanted to do a native compilation, so who is familiar with GraalVM? So just a few people. So GraalVM is an interesting project because you can compile your Java artifact down to a native binary, which is interesting in a container and especially a serverless environment because it allows you to start up your application much faster, uses less resources because there's no JVM anymore in your container image. There's some downsides too, so it's not for everything and anything, but it is interesting. And with Quarkus, what you can do is you can just do -- native with your Quarkus CLI, and it will do a native compilation of your application without having to have necessarily GraalVM installed on your local machine, because it, again, tries to help the developers in their inner loop by pulling down a container and then running that native compilation inside a container. So that's kind of a sidetrack while we wait for the compilation to happen, which actually already happened. So now we can do our Docker compose up, and it's going to build the container images. And then in a second, we'll see that everything is up and running in the containers. So now we can see that a bunch of different applications are running. Here we have our camel processor, ingester, UI, and blah, blah, blah. So if we go to localhost 8080, now we can see that our application is actually up and running, orchestrated between the different services, and we can go ahead and vote for the different IDEs. Now, I'm guessing that you want to vote as well. This is running on my local machine, so that wouldn't quite work. But of course, I have it also deployed in a cloud environment, so we can go ahead and check that out. But so this was Docker Compose to help you orchestrate different containers. And then you can see that with Podman Desktop, it also works with Docker Compose, right? So we can see here that this compose file is also recognized here, so we can stop particular containers. So what I could do is, for example, I want to work on this UI part. I'll stop this container. And then instead of having to start the dev services for all the different components, I can just say, I want to just use Maven Quarkus Dev or Quarkus Dev to start up just the UI part of my application running outside of a container, but then integrated with the application. So we can see here that our dev mode is running, and that's, let's see, back to the Firefox. And on localhost 8080, we should see the same thing, except now this is running outside of the container. So I can do some live development of the application. So let's see, source, main, let's see, results. And we can change something, who wins, exclamation point, question mark, I don't know. I'm not very creative with this stuff, but we should see that if we refresh that we have those changes because I'm running this in the dev mode. So I'm getting a quick feedback loop and combining Docker Compose with my local dev services, running them both side by side. All right, so let's go ahead and stop this for a second, and I think we'll go ahead and stop our Docker Compose, and we'll delete that as well. So let's try this on our cloud environment. So I have an OpenShift environment, which is implementation of Kubernetes. And I already have this application deployed here. So we have our camel demo component here. And we see that there's the same thing, right? So the camel demo UI, the ingester processor, the Kafka cluster, and the Postgres database running here. And let's go ahead and try this and see if it works. It takes a second to start up because I'm using serverless. So this only is serving when it's actually being used. So in this case, we can see that I've already casted a few votes, but I want you to vote as well. And let's see what the preferences are here. So I'll share a QR code. And if you have your cell phone with you, let's see what your favorite IDE is. And I don't know if I'm in the way of anybody. Yeah. So the next demo application that I'll show is actually uses gRPC in one component. So Quarkus does support gRPC as well.
Did you have to handcraft that compose file?
So yes, I did have to handcraft that compose file. So that's a little bit of complexity, of course, if you want to go down the route of Docker Compose. So what you could do if you don't want to go down the route of Docker Compose, it's fairly straightforward once you start figuring it out. But another thing that you could do is, for example, with Quarkus, if you add a Kubernetes extension, it will create the Kubernetes manifests. And so, for example, with Podman Desktop, it supports also Kubernetes instances. So you can create, for example, an OpenShift local or a Minikube or a kind cluster. So then you can run Kubernetes on your local machine. So that's something that I also was thinking of showing, but then was like, well, I have to make some choices in terms of the timing. But yeah, so that's an alternative solution. The nice thing with that is that those Kubernetes manifests, then you can pass them on to your cluster administrator / SRE / platform engineer, whatever the title they go with, to get a nice starter for deploying the application. So in the meantime, let's see what the votes are like here. So we can see that IntelliJ is winning, and you can vote as many times as you want. So the fun thing with this serverless is that the more you vote, the more instances are going to run. So if somebody feels inclined to like script this and start sending a bunch of votes, you'll see that these pods are going to scale up and down based on how many times you vote. But that's a different talk. On Thursday, I have a talk with my colleague Daniel O about OpenTelemetry and serverless, and maybe we'll go into more details about serverless there. So in the meantime, we can see that IntelliJ and VS Code are, of course, no surprise, the big winners right now. We have a few votes for OpenShift Dev Spaces. Nice. Ignacio, nice. Excellent. All right, so that's kind of showing you how you can do some inner loop development with some components. And maybe I'll show real quick the how you create the manifests with Quarkus. So in this case, because I already have the Kubernetes extension installed on this application, we can see that, and in this case, an OpenShift extension, you see in my targets for my Java application, it does actually add the Kubernetes manifest, so you can see like a service account and a role binding, because it needs to connect with some config maps where you put your configuration basically in Kubernetes. So it generates all that information for you. So that's pretty handy to have, right? So then you can just apply this to your Kubernetes cluster directly. So let's move on to the next part, because we're not done yet. Because right now we had a complex application. We had 3 different components. But what if we have even more, right? At some point, I can't run them all on my local machine. I have to use some remote, some remote services, right? Because at some point, my laptop is gonna say like, well, that's too many. I can't run this on my local machine. So this is an example of an application that has a little more, a few more components. So this is the Quarkus Superheroes application, which you can find also in if you go to the Quarkus examples. So this is a little might be an understatement. This is quite an over-engineered application. So basically, it sets up these two superheroes that need to, well, there's a supervillain and a superhero, and they fight, and then based on the properties of each one of these characters that randomly gets put against each other is going to decide who wins. And so basically, it uses gRPC, it uses a MongoDB, it uses a Postgres database, it uses a Kafka topic as well. It uses even some AI. So any of you using LangChain for J at the moment for Java? For doing any kind of AI stuff? No. So this is also something that's supported in Quarkus. So it makes it very easy to interact with an LLM, with a large language model. So with OpenAI or with Llama or whatever. So definitely check that out if you're interested in just trying a little use case with AI, because they're bombarding us from left and right with AI, so we might as well try it out. And Quarkus, like everything else, tries to make that as easy as possible. But yeah, that's not necessarily the talk of today. The talk today is about how can we do our local development with such a complex system, right? Because at some point it becomes a little overwhelming. So if we take a look at how some solutions for this. One is a Quarkus-specific solution, which is Quarkus Remote Development. So that same kind of dev mode that I was using on my local machine, I can also use that with remote systems. And so the way that works is I basically have to configure and tell it, here's the service running remotely, and a password to make sure that when we're connecting to this remote service that it's us, and then we basically run a mutable jar on the remote system that Quarkus can then update on the fly as we're doing our development in our IDE. So that's one solution that you could do to kind of circumvent having to run all the services on your local machine. So with the Quarkus Remote Dev, you're actually running everything remotely, even the service that you're working on, but you do get the advantage of the Quarkus dev mode with the live reloads and all those different components. So you can see here the way that would work is we have this one service here, the REST fights service that our Quarkus Remote Dev is targeting, and then as I'm making my code changes, is going to every time make sure that that's in sync with that. Well, it's going to change the mutable jar because that's kind of in the name, right? A mutable, changeable jar. So that's one solution. Another solution is to work with a system like Skupper. And so Skupper is a way to interconnect different applications across the distributed system, even across different clusters, and potentially even between cloud services and services running on a local data center or your local laptop. So that's the solution as well. So it works on a layer 7, so you don't have to worry about setting up like networking and VPNs or anything. You just set up the configuration and it's going to interact. It's going to let your applications interact, acting like they're all in the same local network. So that's a pretty neat solution as well. And that's kind of the idea behind this third solution, which is JKube. So JKube does sort of the same thing as the Quarkus Dev Mode, except in this case, we actually have the application running on our local machine, and it's going to tell Kubernetes basically that it should send traffic to this local service while I have this remote service up and running, and basically your local application is running on your local machine, but your cluster thinks that it's just in its own network. So that way you can have all the advantages of like for example the Quarkus Dev mode as well. And then if you're a Spring developer, this works for you as well. So this is a nice kind of extra if you decide to stick with Spring. So let's try that out, right? So here you can see again, this is a very kind of fuzzy image, but just imagine that it's very sharp. We can see here in the middle is our REST service. So this is running this is going to run locally on my machine, and everything else is going to run in the cloud and then connecting with this service. So this is going to be our next demo with JKube. And then after that, we'll finish things up. So I'm not going to always use VS Code, right? I try to be agnostic. So here's IntelliJ for you this time, since IntelliJ was the winner, right, of the voting. So let's go and find where IntelliJ is living. There we go. And here, so basically what you need to do to enable JKube is you add a build plugin. So this build plugin, org, Eclipse JKube. In this case, I'm using OpenShift, so there's an OpenShift Maven plugin, but there's also just a regular Kubernetes Maven plugin if you want to use a different cluster. And then you can see here there's a remote development part with a local service, REST fights, running on port 8099. And so that's what I'm going to start on my local machine in just a second. And then it's telling it that there are other remote services that should tie into this service. And so what's going to happen when I start this remote mode with JKube is that it's going to go out to the cluster, tell it, hey, replace this service with the one that I'm running on my local machine. And then I can do my development that way. So let's try it. So I should have it in my history. If not, we can just do OC, no, Maven OC remote, I think. No, I'll go to my cheat sheet, OC remote dev, okay. Oh, I don't know why I capitalized the dev. Oh, Maven. Wow. That should do it. So now I'm going to go out to my cluster if I'm connected to it. Let's make sure that I am. Okay. And we can see that some services are available on my local port, and those services are running remotely. And then my local port is now available on the Kubernetes cluster as well. So now I can say I want to start my application here in debug mode because I want to debug a part of my system. So in the meantime, I'll go to my cluster here and go to our Quarkus Superheroes application here. And you can see, all the kind of complexities of this thing. So you can see there's quite a few different services, right? That would be not so fun to set that all up on my local machine, of course. This is the service here, the REST fights that I am running on my local machine. So let's take a look and see if this is up and running. It should be, let's give it a little bit more time. I think it's running right now. So we'll go to the application. And I should find a UI component here somewhere. There we go. Let's go to that, open. And we can see that this is the UI. Again, my colleague made this. It's definitely better than my UI skills. Maybe it could still be improved, but I'm not going to tell him that in person. So we have some superheroes. We have, for example, Batista against this Void, Ghidorah. And if I refresh, sorry, I could have just clicked the new fighters. We can see that there's new fighters and we can have new location. It's just kind of this imaginary thing. But so now I want to have some debugging to see, what determines who's going to win this fight before I click this fight button. So if we go back to our application here and we go to our fight resource, there's a perform fight method, and basically that's going to call this service to perform the fight and determine who's going to win. And as you can see here, I have already a breakpoint set. And because I'm running in debug mode on my local machine, on my local application, we should see that when I hit the fight button, it should pause. Let's see if that's the case. It's not. So that's let's try that again. So we have our dev mode running on port 8089, and then we have here, let's start this remote dev one more time to make sure that we're targeting the right cluster. So OC project Quarkus superheroes. And we'll start this again. We'll see if this works this time. If not, you'll just have to believe me that this totally works. All right, so waiting for the cluster and then setting everything up. And then we're exposing port 8099. And then let's try it again. I'll hit refresh here. And then hit fights. Okay, so now you can see that it is paused here, and we can see that IntelliJ is saying like, hey, there's something happening here, and it hit our breakpoint, right? And now we can see in our fight request here, we can see that the hero, Black Widow, has level 73, and this villain has level 2 million or something. And basically, it sets up these levels, and then if they're close, it'll try to do kind of a show off, but in this case, it's pretty far apart, so we know that the villain is going to win, right? Based on the data that we're seeing here. So let's go past our breakpoint, go back to the application, and the villain would have won if. There we go. All right, so you can see this is kind of the idea of this application. And so we get some insight into our application. I can do live development. I can make changes on the fly and affect directly this remote service. So that gives you the opportunity to work with remote systems in a more manageable way. So that's some ideas of how you can work with distributed systems and do it kind of with quick feedback loops without having to redeploy, recompile, redeploy, rebuild, whatever. So hopefully this was helpful to you. If you're interested in the other side of the picture, I'm also doing a talk tomorrow about the outer loop, where we're going to automate the deployment of applications with CI/CD and with GitOps. So if you're interested in that, I'm doing that talk tomorrow at 2 p.m. Featuring Tecton, Argo CD. We're also going to make sure that what we're deploying is secured, right? So in terms of creating software bill of materials, signing the images and all that stuff. So that's also pretty relevant these days. So if you're interested in that, definitely take a look at that. If you like free books, our developer program is nice enough to sponsor books that our team and that some other writers write, and then they're available here to download. So for example, if you're a Spring developer and you like Quarkus, or maybe you're interested in learning more about Quarkus, there's a Quarkus for Spring developers that will help you get up and running with some ideas of how to migrate from Spring to Quarkus. There's the Java in a Nutshell, which is a very nice book that you can download also for free. And then if you want to get into the whole Kubernetes world, there's books for that as well. So, and then maybe personal shout outs for myself and Daniel is that we're writing this book on serverless Java, which isn't available yet, but should be soon in early access program. So keep an eye out on that. Maybe you can connect with me, and then I'll keep you up to date. And then definitely check out the Red Hat booth. We have some cool goodies. You can come ask me questions. I'll be around there. And if you want to try out some stuff or have some technical questions. And then here's some other talks from my colleagues if you're interested in more content. So this afternoon we have a session on Quarkus 3. Tomorrow we have sessions on also trying to simplify Kubernetes. Like I said, CI/CD and GitOps that I'm presenting. Ansible, if you're interested in that. And then on Thursday, I'm also doing a talk on distributed tracing with serverless Java and OpenTelemetry. And that's it. So thank you.